and then I started to teach it. So what does it mean when I'm starting to record? Means you have access to that. If for some reason that you couldn't connect to the Wi-Fi or something was wrong and you couldn't attend to this what is class or meeting, so you can just watch the video later. So the video is just really same thing, I mean same interaction, everything is recorded right now. So then I will get a link, hopefully this is just really the testing, and then I will post the link to you that whatever we have done right now. Okay, so again, the videos which is posted from last night is perfect, so you can watch them. If you have any question, anything that you want to ask, is just really coming to this time, be on online and ask me. But it doesn't mean that's the only time I'm available. If you need me to be available through the Zoom any other time, you can shoot me an email and I'll try my best to make it. But that's just the lecture time for us, similar to the classroom. So you can just stop me whenever you want. If you have any question, I just try to be on the schedule, okay? So the best thing that we can do is at this time, make the classes on time, make every single thing that has been scheduled as usual, and then we are good when the time that we go back to the classes, okay? Except the exams, which I have no idea as of now what would be the best way to do, okay? But we will find out by tomorrow what's the best way to do with the exams. If you have any other question, I'm waiting for your questions before starting the lecture. Any question? No, not at all. Keep going. Yes, you can.
Can you hear me, Professor?
I think, yeah. That's a good idea to use the mic. If you're using the mic, can anyone else say, is it just the only, I mean, am I the only one to hearing everyone else, or is just everyone hearing each other?
I can hear everybody.
I can hear.
I think I can hear everybody.
too. Yeah.
I can hear.
Yeah, I can hear everybody.
Okay. So that's
Hello?
just, yeah, I can hear you. Who was the hello? And then, so just if you have any question about anything, ask me right now. If not, you can always email me, okay? And I think, yeah, if you don't hear anyone else, do you hear me? If you hear me but not hear anyone else, so then that's just a problem that, because as long as, yeah, on the mobile.
It's a what?
Yes, because somebody is asking, she can't hear anyone else. And then she said probably she's on the mobile, and that's the problem. I can't hear everyone else. You have to join to the call. So yeah, that's just, if you are on the mobile, you don't hear each other. You don't hear anyone else, but you hear me. Okay. Yeah. Okay. So then you are fine. I'm sorry. I'm reading the message. Everyone is else. So everyone else is trying to join me to the web version. Okay. So it seems we are fine. If you are, yeah, seems we are fine. As long as you're hearing me, and then your mic is on, is perfect. So if you want to talk, that's just whenever you want. If you just start talking, I stop. Okay. So then I explain it. Thank you guys. Thank you for helping each other. I'm just reading the messages. So as we started last time, we are trying to just complete our chapter 12, which I gave you the overview of the chapter 12, and I'm going to repeat one more time here. So in chapter 12, what's going on? I have to learn about what to do with the multi-variable, or how to integrate multivariable functions, okay? So there are two types of integration over here, which one of them is double integral, and the other one is triple integrations. So in each one, I have different coordinate system to do it. So you can stay in the same coordinate system, which is just a rectangular coordinate system, and do the integration. You can move to the polar system and do the integration. Obviously, we just move to the newest coordinate system only to make the job easier, to make faster integration, or somehow shorter even integration, okay? So this is when you're moving to the polar. And then there are three options when you are having the three-dimensional coordinate system. You can stay in the same coordinate system that we've been, which means that's just rectangular coordinate, or you can just move to the polar but three-dimensional version. That has a name, we call it cylindrical. So cylindrical is the one that we move it to the new coordinate system of the polar, but that has a z value because it's three-dimensional, that's why we call it cylindrical one. And the last one, which is a brand new one, is just when you move it to spherical coordinate. We haven't seen it, so we need to learn it. That's 12.6. So this is what we call a spherical coordinate. Obviously, as I said, this is just to make our job easier. We're moving from here to here. If it is easier to do in a spherical coordinate, we just try to do it in spherical coordinate. So what's the difference between each of these? There is obviously relations that we want to find out. What's the relations? Even actually we know what's the polar, what's the relation between polar and what is it here? The coordinate system. If you don't remember what's your polar formulas, is fine. I just need very simple formulas and I can remind you what they are. Then the goal is, however we are learning what we call double integration or triple integration, use this new coordinate system to make the job easier, okay? I think in your class, I have started chapter 12 last time. So means we have really simple example how to integrate in double integration, okay? So I'm going to move on, but first I just want to make sure everyone is okay and you're hearing the voice and you can follow what I'm talking about. Do I need to add anything? Everything is perfect?
Yeah.
Okay.
Yeah, everything's good.
Okay, let's move on. When I have definition, which we call Riemann sum of the single variable calculus, as I reminded you last time, and I just repeat one more time. The whole idea for all of the integration that I have listed right now, means 5 of them, is really start to chopping to the pieces and pick a lucky point and then make a Riemann sum. So we want to do the same process that we have done in calculus on to define what I call the new coordinate system and then later on use it. So all of them is coming from the Riemann sum. We can define and then we can just make a rule for each of them how to set the limits of integration, okay? So we have done the main process, which is make the Riemann sum for double integration. I think we did just only one simple problem last time. So what we have done last time was just really make this graph on the board, and then we just said, okay, so this is going to be chopping in the x direction, this is going to be chopping in the y direction. So that's this just really delta x, this is just the delta y. So then delta a is going to be delta x times delta y. And then since I'm looking for the volume, this is going to be the area of the base, which is delta a. And then when you multiply by height, so you just have the volume of that little column. And since you want to have a better approximation, to let you let this number of rows and columns to be more and more. So that means just you have to set these numbers of n and m approach to infinity. So then you have had better approximation, and at the end we call it what we call double integration. I think we haven't tried any example. Can you please remind me? Where did I stop?
We did example 1.
So it means we did only one problem on this one, huh? We have done this one. Is that true?
Yeah, that was the one we did.
Okay, so that's the only one that we have done. Okay. how about this volume problem? Did we? No, right?
No.
So this is just, we haven't learned anything about integration, right? So this is just really, we haven't tried any formulas to integrate. This is just first thing that we can do to practice the concept, okay? What is the concept? It says if you want to get the volume of any, if you want to get the volume of any of the surfaces, so when you just have the z equals, sorry, I forgot to bring my pen. So if you have the z equals f of xy, and your goal is to get the volume under that surface, concept says, okay, do the double integration. That gives you the volume, right? Do the double integration, that gives you the volume. Number one. And then what's the limits of integration? What's the area of integration is going to be the, whatever is the limits for the x and y, which is given to me, and that's called R here, okay? So for now, I don't know that much about integration. I just want to use the concept of what I have said right now. It's just the volume, right? So the main thing is, what's the equation of the function that you're supposed to integrate, huh? So what's this function? If I know what's this function, I can just really use the geometry. I don't need to know that much about integration to do it, because all I know is the whole thing is going to give me a volume of solid which is under the surface of this, okay? So do I remember from chapter 10, 11, what's this surface? Maybe not, because I've seen it in just standard one. The things is just really solving for z, because this is the way that function of two variable is. So then I start to square both sides. So then I have x squared plus y squared equals 1. Oops, sorry, z squared. I don't know why I wrote z squared. C squared, where is the eraser? Why I lost my eraser? Something is, no way, I lost my eraser. Last time when I made this problem, I couldn't do anything unless I just restart the whole meeting. Sorry, I hope that's not the case. For now, I just undo to see what happened. Yes, I lost the eraser and clear button here. I don't know why. So then I have this equation. Do we know what's this equation? No? Yes? Looks like circle.
Circle.
Anyone?
Circle.
It is a cylinder, huh? It is a cylinder because it's a circle in three-dimensional, huh? So this is going to be a circle in three-dimensional. And I'm going to make the half cylinder, not entire cylinder. Anyone knows or remember why? Anyone knows
Because
why?
of the square root.
Because it's the square root, right? So it's not entire one. It's not entire one. It's just really half of that. So this is going to be my cylinder, okay? So this is going to be my cylinder, and that's just really what's the region supposed to be, okay? I have made it in the halfway because of here it's not plus minus. If it was plus minus was entire, but when it is only plus, so it's just going to be the top half of my cylinder, okay? So the top half of my cylinder is what I'm looking for. And then I know geometry. Geometry says the volume of the cylinder is going to be pi radius squared times height. So I know what's the radius. This is just the radius. This is just really 1, and that's just the other side is going to be -1. So what's the height of this cylinder? It says right there, -2 to the 2 is the y values. So you have started from -2 and you ended by 2. So it's between -2 and 2. So it's 4 units. Is that true? Okay. So what it is over here, you have to say, I'm looking for half of the volume by this form of integrand, which is by geometry is going to be pi radius squared times the height, and that's it. Then you're done. So I didn't need to know that much about integration or calculus 3 unless just really this. So it says you'll have what is the volume by just doing the double integration when you know what's the graph of your integrand, okay? So as I said, everything here is just based on my integrand or the graph that I have learned in previous. Excuse me. Is there any question about this? I don't know, is the voice from me, the noise is coming from me or from somebody else? Hmm.
Not yours, it's someone else's.
Do you have any question about this problem? Is there any question about this problem?
Wait, so all these lectures are posted on YouTube as well?
This is a very good question. I don't have any answer for that right now. Yeah, because you see, I have tested in the morning for about 11 seconds, and then the system, which means Titanium, must send me a link that is recorded, okay? All I know right now, this is recording. And then since the length of the lecture is too long, it seems it takes time for them to just put it on cloud and then I can get the link. For the morning class, which is about 2 hours from now, still I haven't received, and it says processing to record. That's just weird for me. So I'm hoping after, as I press the record, and as you see, it's recording right now, after finishing this one, after a few hours, I will get a link that is just saving in cloud, and then I will provide that link to you. I don't think it goes to YouTube. I think it's just really somewhere in our Titanium system. I don't think it goes to YouTube. But if not, again, remember, I have posted some YouTube videos, which I love them. They are really great. So you can just check those too. But the purpose or the goal is to keep this one recorded and to send the link later for anyone who is missing the meeting.
Okay, thank you so much. That clears it up, yeah.
Yeah, okay. And as I said, my problem right now is the technical problem because I lost the eraser button. And then if I have that problem, this is what happened. You see how it's bad? These are moving with my slides. And then I need to, why it's half of volume? Why you don't talk? That's easier. Okay, why it's half of volume? Who was asking? I forgot to look at the name. What's the half of volume? Because as you see over here, if it was the entire cylinder, it has to be z equals plus minus 1 minus x squared. So that's include the top of the cylinder and the bottom part of the cylinder. But my problem in the integrand doesn't have a negative sign. It's only positive. So that's only positive piece of the cylinder which goes upward, not the downward piece. That's why it's half cylinder. Does it make sense? I forgot to look at your name when you were asking question. Does it make sense? The person who asked me. Should I go and change? Who was it? Yes, there was a chart.
I have a question.
Please go ahead.
So we're just looking for the volume for this problem.
Mm-hmm.
And when it says evaluate the integral, I'm a little bit confused with that.
We did evaluate the integral, right? So it was just the number is going to be 2 pi, and that's the value of the integration.
Okay.
Do we have any other way to do it? Yes, we are learning the other easy formula, which is going to be polar, because that's easier to do in polar in about 2 sections.
Okay.
But for now, it's just going to be based on what we have learned in geometry.
Okay.
Okay.
Thank you.
No worries. Any other question? Move on. And as I said, in the morning, I had the same problem. The only solution for me was to really raise, to end the meeting and start again. And I don't know why this is happening. Do you see what's happening? I can move my slide to go to the next one, but this notes is coming with me. And then anyone knows what's?
What program are you using to draw on the slides?
I have, so this is just really Zoom itself, and I have shared the PowerPoint that you have through the Zoom. I have nothing extra than that. Do you have any idea? Who is talking?
Possibly. Oh, it's Luke. Possibly we could just screen record a different program, because I think like Zoom can possibly record like external programs, right?
Mm-hmm. So possibly, what do you mean by possibly? Should I do?
Oh, I'm thinking maybe we can mark up the PowerPoint in a different program and just have Zoom record that program instead.
You know, that was my plan at the beginning. That was just what I was doing to do with this. The iPad that I'm using to be my written thing, and then talk to you through the computers or just the laptop. But the sound of the iPad from morning, I don't know how this, whatever I mute on the iPad still has a sound. And then these two sounds that come together, it makes the echo.
There's an option in view options for annotate. I don't know if you see that.
Annotate, no, I don't see annotate.
Okay.
PC, I see it. In iPad, I don't see it.
Oh, okay. So there should be an option to annotate, and then it brings up the menu to draw text and clear.
Yeah, that's the clear is not working. Okay.
I see.
I'm so sorry to say, but I remember in the morning that was the only solution. Is just for now end the meeting and I'll come back in a second. Okay. So then I'm hoping that comes and I can clear everything in next one. Okay. So in a second I'll go and come back. Okay. Sorry.
Is everyone else here?
Yeah.
Yeah, we're still here.
Yeah.
So how are we going to do the exams? Are we going to do it here or through Titanium?
Great question. Great question.
I don't think she
No.
said anything about that though.
No. No.
Oh, no exams?
No, she said she's gonna figure it out tomorrow.
Yeah.
Oh, I see.
Like the school's gonna let her know.
Very low key safe.
Professor, are you back?
Oh, sorry. Now, do you hear me?
Yeah, we can hear you.
Yep.
Okay,
Yeah.
so now I have that erased thing. Okay. Okay, now I'm fine.
So we all had a question, Professor.
And that was about I was hearing you.
Oh,
So
okay.
that was about the exam. And I
Yes.
said, no one knows as of now. We have a meeting tomorrow with the department chair. And then there are many options available. So we want to see what the department chair will say tomorrow. What's the suggestion tomorrow? Then we'll find out and I'll let you know. Okay. So there's no news as of now. I don't know.
All right. Perfect. Thank you.
Tomorrow. Okay. But we have time by the exam. So the exam is about 2 weeks. So we have plenty actually of time, and then we have many things to cover by that 2 weeks to see what we can do with the exam. So there, as I said, there are many options to see which one is better. Okay. So if you see the screen, everything is fine now, guys?
Yes.
Okay. If you see the screen, it seems whatever we have done in calculus 1 still is going to be same process, same rules, same table of formulas here, including the 3 of them which is listed over here. So what it says if you have a integration of addition, if you need to split it out, you can split it out. So integration of addition is going to be addition of 2 integrations. So I can separate it out, and the same as for subtraction, I can separate it out. So if I need it. And then one more thing that we have had for single integration, double and triple is going to be the same thing. If we like to just factor the screen out, sorry, the scalar out, we can do it. So it's fine. So we don't have anything to do with the scalar. We can always factor it out with the single integration, double integration, triple integration, and more, okay? And then one more rule that we have is when you have an inequality, if you have inequality, so you can just always single integral both sides, you can double integral both sides, you can triple integral both sides of this equation, okay? So it's fine to do any type of integration both sides of the inequality, which is kind of, I will say, interesting, because usually when you have inequality, you have to be careful. You might multiply by negative, or you might divide by negative. So somehow you need to switch, be careful to switch the inequality. Seems the integration does not do anything, right? So integration for single integral is doing the area, for double integral is doing the volume. So that's why it seems it doesn't change the inequality sign, and it stays exactly the same way it is as you want to double integral both sides or triple integral both sides. Make sense? Yes. Move on. Okay.
Yep.
So how do we integrate? Is just really what you did in differentiation, right? So you partially differentiate. Now you have to partially integrate. So you do integration partially as you do differentiation partially. So this is what we call partial integration. For example, if you want to integrate partially in terms of the y, you have to fix your x. So partial integration in terms of y means fix your x, or x is a constant, okay? Then you are starting to integrate in terms of y. So similar to partial derivative, you can partially integrate. So it's very similar to that idea. Table of formulas, exactly same as what you have seen in calculus 1, okay? Make sense?
Yeah.
So what is really the order of integration is, or which one is first, which one is second, is really same as order of operation, right? So if you have this form right over here, this means this is inside. And then we've learned in algebra classes for years, we have to start from inside and then you go outside. And that's what's happening here in order of integration. Whatever is inside, you must start it first. When you take care of your inside, the result goes out, and then you do the next step. So does it matter I have dy dx? Can I make it dx dy? Yes, it's just really whichever is easier. We select, and we want to practice right now. Whichever is easier, we do that order. But I have to always remember whatever is inside is just first, and whatever is outside is next, the same as order of operation, okay? Makes sense?
Wait, so you can switch them around and it'll still come out as the same outcome, right?
This is really same if I just switch them around, exactly. But I have to remember, if this is going to be dy first, this is the limits of the y.
Yeah.
If it's going to be dx, this is the limits of dx, huh? So when you switch them around, don't forget with the limits, not only this part, huh? So limits.
Yeah.
Otherwise, yes, exactly same. Makes sense?
Mm-hmm.
Question?
Good stuff.
Okay. And this process that you said, switch them around or just take care of the order, it's called iterated integral. That's the name of making dx dy dx. So that's called iterated integral. And that's exactly to answer your question. So what it says, if you have dy and then you have if you have dy and then you have dx, then you have dx and then you have dy. So you can switch them around, yes, but I have to be careful about when I'm switching, just switch the limits of integration too, right? So you have to switch the limits of integration too, but you can do it always. Fine? Okay. And then again, like the order of operation, you always start from inside and you go out. Like any order of operation that we've seen, parentheses is first. So you start from inside and then you go outside. So I have one example here to practice. And this is going to be what I have dx first, and then I have dy next. So to start, I can just make the parentheses at least for a while. I don't have to do always because later it's going to be clear. For now, I will say, okay, this says you have to take care of your dx first or integrate in terms of x first while y is fixed and then dy, okay? When so this is the outside, and I'm going to keep it exactly same way. I don't touch the outside integration, I just do the inside first. So anyone can tell me what would be the integral of y cubed e negative 2x when y is fixed?
2y cubed e to the negative 2x.
So just because we've seen, for a few weeks we were trying to do derivative. This is a common mistake. You think you are in derivative, but you are in integration.
Oh,
So you have to
yeah.
integrate. So then that would be EAX divided by A. So that's true. It's just going to be exactly e to the negative 2x divided by negative 2. But you need to evaluate from, what was it, from 1 to 2. Okay. I don't know whether you remember it or not, but I said there is no indefinite integration in entire calculus 3. There are always definite integration, means there are always limits, and you always need to plug in back to see what's the value, okay? So if I plug in back, this is going to be negative half. Plug in x to be 2, minus, and then to the negative is plus, so e to the negative 2 times 1, and that's just a constant. So as I said, I prefer to bring the constant out, so this is negative 2, e to the negative 4 out, this is 1/2, e to the negative 2 out, but from now it's just really calculus 1. It's simple integration in calculus 1. So I can take care of this part in calculus 1, and these are constant. I can just keep it outside. If you like to make it positive power is fine, but for me this is fine, okay? This is going to be y to the 4th divided by 4, plug in 0 to 1, and that is what? Negative half e to the negative 4 plus 1 e to the negative 2, and then 1/4. That's the answer. I don't know how you are doing right now. Just anyone is trying to take the notes?
Yes. Taking notes.
Can you do it as I'm just talking, or do you need more time to write down?
I got it.
Anyone else?
Yeah, we're good. We're following along.
Yeah, ready.
Maxine, no time. Maxine said no time. So, question, as she's writing, any question? Any question? Okay, move on. Okay, thank you. So this, as you see, has the second problem, as you see, has the same letter, because this is really same problem. So there is a typo over here. Let me fix that typo. So this is B, this is B, both of them are the same. The only thing is just the order of operation. This is, sorry, the order of integration. This is Y, which is from 0 to 1. And this is X, which is from 1 to 2. Is it fine? So here is going to be dy, and that's just from dy is the outside one, right? So from 0 to 1, so this is a typo, okay? And this is a dx. And dx is from 1 to 2. Dx is from 1 to 2. So as we said, it's fine to do either one. It's just really cool. So they are really same number. Is the matter of which one is easier, which one we just do it without any techniques of integration. That's just what we need to decide. Is it easier to integrate this one in terms of y first, or is it easier to do this one in terms of x? Any idea?
Probably in terms of y first.
Y first, because if I do it in terms of x, I have to do integration by parts.
Yeah, true.
Product of two functions is integration by parts. We don't like to do integration by parts because we have easier way, right? So this is easier. The y is easier. The first one is easier. Why? Because you just have only x constant, and then you have only y over here as variable. So same story. You just keep the outside as it is, and then you integrate in terms of the y. So this is a constant, and then one more time to remind you, I am doing e to the constant x dx. So integration is going to be exactly same divided by the constant. So integration is going to be exactly the same divided by the constant. What's the constant when I'm integrating in terms of the y?
X.
So you divide by x. Thank you, Niste. So then I have from 0 to 1, and then I need to evaluate. So the good thing is if I can change the color. No, it's here. Sorry. If I can change the color, so this by eraser. Sorry. So I have to say undo because I lost my x, and then pen. This by this cancel out. Okay, this by this cancel out. So this means you just have really nice integration. So you have really nice integration. What is it? It's e to the plugin. This is the y value. This is the y value. So plug in y to be 1. So it's just x minus plug in y to be 0. So it's e to the 0. And then you just have easy, nice integration. Okay. So this is going to be e to the x, exactly same. And that's the constant. Integration of constant is x, right? Integration of constant is exactly x from 1 to 2. Am I fine? Is it everything okay by now? This is going to be e to the second minus 2, and then this is going to be e minus 1. So whatever, right? It's just really a number. And then the question is, can I do the other one? Why not? You can do the other one too, but it takes time. So for the next example, which is very similar to this one, I will do the easy one, but the hardest step is in this slides. Okay, so you can check what is the integration by parts if you don't remember. Okay? Question, guys?
No, we're good.
Anyone?
This is actually really fun.
I love it. Why? Because you don't have to waste your time to drive to the school and then the lecture is really the same thing. The only thing is we don't see each other. I really miss you. Honestly, I miss all of my students always, and I'm hoping we can come back after about a month, and then everything is normal. So wash your hands, okay? Be careful. Yeah, I agree with that. So any other question? Move on. And this is just practicing same problem. Okay, so you can just read through. This is doing in both ways, and just proving is giving you the same number. Okay, so the theorem, that's just really the guarantee or the permit to able to change the order of integration is called Fubini's theorem. So Fubini's theorem says you are fine if you have had dy dx, just move it to the dx dy. Okay, as long as you are be careful about this limits of integration, that's just perfect. Okay, so that's a Fubini's theorem. Fubini's theorem has really many versions, many dimensions. So this is for 2-dimensional, and then we have it for 3-dimensional, and we have it for more too. Okay, so Fubini's theorem works for any dimensions. That says you can always reorder the integration. You do whatever is easier for you to integrate. Okay. And another example to practice iterated integral means there is no order here in this problem. As you see, there is no order here in this problem. So then you can just really decide, is it easier to do dy dx or is it easier to do dx dy? Okay. So dA means either is dx dy or is dy dx. So then that's limits of integration. The first number goes with the x. The second number is just for the y. And then this is just up to you to decide whichever is easier, do that one. Any idea? Yeah, Brooke says x is easier. Yeah, x is easier. Any more comments?
Yeah, X.
Yeah, x is easier. Why? Because again, this function is product of two functions in terms of the y. If I want to do in terms of the y, I have to do the integration by parts. I'm too lazy to do right now, so we just go by this time. So that's just really the techniques. It's not really because I am lazy or you are lazy. It's just really the techniques. So we have to know whichever is easier, we do by that way. Okay. So then this is going to be, as you said, dx first, dy next. And that's just going to be y sine of xy. Okay, so limits of the y goes first, right? So limits of the y goes first. So this is the limits of the y. So it's just from 0 to pi. And then limits of the x goes next. So this is going to be from 1 to 2, right? So that's fine. I'm going to take care of my x first and then the y. So I can just put the parentheses to make sure y I am doing x first because that's inside. So what's next time? The next one is just one more time to remind you, if you have had sine of constant times x is minus cosine of same thing divided by that constant, obviously plus c. Okay. So we don't have constant here because it is definite integration. So this is the integration in terms of the x, and the y is constant. The y is constant. Okay. So sine is cosine. Divide by, what's the constant? One more time. What's that constant if I'm integrating in terms of the x?
Y.
So you divide it by y, and that's just perfect. This is what we like, huh? What we like because it's just really canceling out, huh? So that makes it easier. This is just really canceling out, but you need to plug in the values. Okay, so let me change my color. So you have to plug in from 1 to 2. And then if you just maybe sometimes at the beginning, it's a little bit confusion. Am I plugging for y or plugging for x? So if you don't know which one is it, so since you were actually integrating for the x, so these are the x's. So for a few times at the beginning, you can write, okay, this is x's. So then don't make a mistake and plug in wrongly for the y. So this is going to be integration from 0 to pi minus cosine. X value was 2y minus cosine the y, and that's it. The next step is really calculus one, right? So it's just really integration in terms of the y. So again, if I need to remind you, this is going to be cosine of constant. X is sine of constant divided by a plus c, right? So that's the formula. So I have minus sine divided by the constant and then I have sine of the y, and then you plug in from 0 to pi, okay? So whatever, right? So it seems everything is constant, huh? So it's minus sine of, everything, sorry, 0. Divide by 2 plus sine of pi minus sine of 0 divided by 2 plus sine of 0, since everything is 0. So the answer is there. So one more time, can I do it the other way, or can I make it first dy and then dx? Yes, you could do it, but that's just really integration by parts and it takes time. And actually in the slide is both ways. That's just to show you, okay? I'm not going to just do that one because it takes time, but it's possible. We don't like it because it's longer. Question, comments? The exactly same way that we, so sorry, I should read the question too. So question was, how do we figure out which one is easier? As you know, the easy way is just really calculus 1, right? So calculus 1 was only if you have a table of formulas, so means you can just really say this formula says integration of this is this. That's number one. Number two, if you have something to do with u substitution, this is still I call it easy way, but if you move somehow to level of calculus 2, means you need to use any of the techniques of integration. So that's just something we don't like it, right? So that's, I don't call it hard, but it takes more time. So easier way is the, you could do it based on your information of u substitution and table of integration. That's what I call easy. Dorian, did I answer the question? Okay. Any other question? Any other question? Okay, move on. Yes. Okay, so I erase this one and then I can just move on. And as I said, this is the easy way we have done, and the other way, which is the longest one, it needs to be with the integration by parts in a way that you don't remember integration by parts. It's right here, but somehow, somewhere, I will remind you one more time, okay? So this is just the longer way, which we don't like to do it because this integration by gives you the same answer. So this is just reminding us, and one more time, it doesn't matter how do you, it does not matter how do you evaluate anything. It's just really how you have decided to choose the order of integration, which is simpler. Simpler means I don't want to go to the techniques of integration yet, like trig substitution. Integration by parts is not bad, really. We do it if we have to, right? But that's not really that much bad. But trig substitution or any of the other techniques that we've seen it in second level of calculus, we don't have to use it over here. What do I mean is, if you get to that point that you have to use the trig substitution, you made a mistake. So there was a way to switch the order of integration and do the same problem without that things, okay? So this is just really, I will say, the reminder. If I had to do something hard to integrate, if I had to use any of the techniques of integration in calculus 2, it seems there is something somewhere wrong. I have to go back and check, okay, should I reorder the integration? So then I do have easier way or not. So that's just the sign for us. No? So sorry, the question was, will you ever ask us to do the harder way? No, that's just up to you. No.
So quick question, why does the order of integration not change the answer?
That's a very good question. So that's just because of the graph. So let's just say you have to find the, so you have to find the volume. This is just whether y is from C to D and x is from here to here, so which is, I will call it from A to B, and then you just want to get this Riemann something that we have had, and then there was a roof there, which is just the function of two variables or three variables, okay? So when you are getting the area of the base multiplied by the height, does it matter you multiply width times length or length times width? It doesn't matter, right? So when you are switching the order of integration, basically it's just really, is it delta x times delta y to make the area delta A, or is it delta y times delta x to make the delta A? So it doesn't matter.
Okay, when you put it that way, that makes a lot more sense.
Yeah, I know. Any other question? Okay, move on. So I need to remind you, last time, this is exactly the first example that we had done. Sorry if the powers is just really does this way in the PowerPoint. So this means a square and this means a square if you see it in this way, okay? But I want to remind you, this is the exact same problem that we have done in the last class, as was just this form. And then it asks us to integrate over 0 to 2 cross 0 to 2. And then it says, make it in 4 squares. So the pieces was four squares. So means you just have had this thing. And then it asks us to just make these corners and then get the volume by using the Riemann sum. So then we have evaluated every single of these points. And then we just multiply by delta A, which was 1, and then we got the answer is 34 approximately. So this is just really one approximation that we got last time. So and then the exact value is just really using the formula, because when I'm using the formula, I'm doing the double integration. And then when I'm doing the double integration, basically means you have set n to be more and more to the infinity, m to be more, and so your number of pieces is approaching to infinity, and that's just what we call the double integration, right? So we have done this one in example number 1 already. So this is your example number 1. So this is just really giving you the exact value by setting the limits of integration and actually integrate by this formulas that we have learned right now. So in order to get to that point, to really, when we see this problem, what I need to do first is just to see the graph. What's the volume? What's the solid? I'm looking for that volume, okay? So then you need to know what's the graph. So again, if you see this one and you check your cheat sheet to see how do I graph this one, that's not coming anything on that format. So since this is not in the standard one, this is just the way that if I know how to use my cheat sheet, is the paraboloid shape. And again, if you don't remember how to graph it, you have to start to make it by level curves. So what do I mean by level curves? You have to say, okay, so if x equals 0, it seems I will get a parabola upside down. If, for example, y is 0, I will get another parabola upside down. If I set the z equals 0, it seems I will get a what is it, x squared plus y squared equals 16. So this seems is just what we call paraboloid. Huh? No, sorry. What's the shape? Ellipse. Okay. So this shape is ellipse. Okay. So this is one parabola. This is another parabola. This is ellipse. Then I remind, okay, so this looks like a paraboloid. Okay. So then I can graph it, which is the graph of the paraboloid. And as I said, this thing is going to be parabola upside down, starting the vertex is 16, and another one is parabola upside down, which started at 16, and this is just, I don't know, I have to divide by 16 everything, huh? So this is what I did. Divide by 16, this is divide by 16, divide by 16. I think this is not clear color, so let me change it. So this is giving x squared divided by 16. This is y squared divided by 8 equals 1. So that tells me this has to be 2 or rad 8. This is going to be 4 units, and that's how you make the paraboloid. Okay, again, in a case that you don't remember how to graph it, but you must, because we have done in first chapter 10 and then again chapter 11, and I said many times there's no way to skip any of this graph. You just need to practice and practice, and that's the place I need it for every single problem, to see the graph, to set the limits of integration. Okay, so that was one. This is this one, the first one. I have made my first one, and then the planes of x equals 2 and y equals 2, I'm going to graph it. So I change my color. So I will say, if I have x equals 2 and then y equals 2, this is just the plane that I will see. So I just try to make a plane right there. So this is where the y equals 2. And then maybe I can use another color to make the plane of x equals 2. The yellow is the worst one, we don't see it clearly, huh? And this is just the planes. The last one is just, as you see, coordinate planes, huh? So coordinate planes means you stop there, you stop there. Okay, so this is your coordinate planes. So if you go and then you make your coordinate planes is one this wall and then one this wall. Okay, and the roof stays exactly the same thing. So the roof still is just right, the parabola shape. Okay. What's the limits of integration? Always two-dimensional graph or base gives you limits of integration. Because limits of integration is dx dy, has nothing to do with the z to move to the third dimension, right? So if I am in two-dimensional, I'm fine. I can just get the graph. So I can just get the limits of integration by the base thing that I have in the here, and I'm going to make it what it is. So that was just x is from 0 to 2, and then y is from 0 to 2. Huh? So this is just the base on that graph, the red part that I made. So the base of that graph. Any question by now? Any question? Fine. Move on.
Yeah.
Okay. So this is the question to find the volume, which is double integration of something. So what's my integrand? What do I integrate?
Your function, the z equals 16 minus x squared minus 2y squared.
Okay. So I will say is always the top, the roof of the solid, huh? So the top or roof of the solid, which is the surface, which is z as a function of xy, is sitting in your integrand. Fine. And then, does it matter which order I go? Is it okay to go by a dx dy or dy dx? Yes, no?
No.
I don't think it matters this time.
Yeah, because the function is just really polynomial, huh? The function is really polynomial. So polynomial can be really in any order, so it's fine. And then limits of integration for both of them. So this is the x is starting from 0 to 2. And this is the y starting from 0 to 2, right? And that's it, okay? So if you have a test, and if you get, I mean, quiz, test, or whatever, if you get by this here, you almost have about 80%, of your credit. Make the graph, set the limits of integration is really the main part of this, any of these questions, because if you are getting in that point, the rest is just really simple integration and you are fine. So this is just really the main job that we have to learn, how to graph, and based on the graph, how to set the limits of integration to get 80%, and then the rest is just really simple integration. Make sense? Move on. First is doing in terms of the x. What is the integration of 16 in terms of the x? x. What is the integration of x to the second in terms of the x? And then what is the integration of y squared in terms of the x? So the y is a constant, so it's just only x starting from 0 ending by 2. This is the dy. And I think this is just really plugging the numbers. If it's 16 times 2, and this is 2 to the third, and then minus 2 y squared, then I have 2 plug in, and the next term is the y. And I can just integrate easily because this is simply 32y minus 8 divided by 3y minus 4y to the third divided by 3 when you have 0 and 2. Sorry, I didn't explain. I did not do anything about the 0, because if I plug in 0, everything will be 0. Is that fine?
Yeah.
So then that's just really last thing. 32 times 2 minus 8 divided by 3 times 2 minus 4 divided by 3, 2 to the second. Oh, sorry, cube. And then I can cheat because we know the answer is 48. I showed you in the last class the answer is 48 when you plug in the numbers. And then as I reminded you, when you have had in previous class as example number 1, approximately you got 34, but it's 48. And we knew it's not a good approximation because it was only 4 pieces there. Is there any question? Sorry, I can't show you the camera because it's just really showing the roof, as the iPad is just on the table, so it doesn't show me. What if the planes is not there? That's a very good question. Okay, so what if the planes is not there? So it's just not really having the right endpoints, right? So if you are done about this one, I can just explain. Can I erase some part, guys? So I can erase here to say in this I will say my lovely graph that I have had over here. If you have had no planes, so then if you have had no planes, so then where is just really my why eraser?
Yes, baby.
This is just really the what is it? What do we call limits of integration, right? So this is just really what the base is cutting in this graph. The original graph is cutting at x equals 0, y equals, sorry, x equals 2, y equals 2. But if it wasn't any plane, it was really entire circle. So which you need to set the limits of integration for your entire circle. And that's just really what we prefer to do sorry, it's ellipse, sorry, it's not circle, it's ellipse. But we prefer to do in actually polar system because it's easier. And that's just tough to do here. Okay, but if there was no constant to cut the graph right there to make that square thing from 0 to 2, so then it's just really entire of this. Any other question here? So Maxine asked me, can I explain the graph one more time? So if I want to explain the graph one more time, I will start over, okay? So this is the first thing that you need to graph. This is the first thing that you need to graph. And then I have two planes of x equals to and y equals to, and then I have coordinate planes. So I need every single thing to show the graph. So then I have the, what is it? Paraboloid shape. Maxine, do I need to explain what's the paraboloid shape? Or just the cutting thing was the problem? Paraboloid. Okay, so this is the paraboloid, which is number one. Number two is if you have the plane of x equals to, so this is x equals to, this is x equals to, and that's just how you make the plane of x equals to. So plane of x equals to is parallel to the YZ plane. It's parallel to the YZ plane. So this is when your x value is 2, and then the y is entire, and the x, so y and z is entire. Okay, so this is a plane of x equals to. Then when the next one is the y equals to, when I say y equals to, y eraser again is coming here. So then when we say the, one more time, when we say the plane of y equals to, so this is the y equals to, which is parallel to the xz plane. So this is going to be parallel to the xz plane. So basically, it seems it's just really like a cake that you have to put the knife right over here and just cut your cake right there. So then the cutting place is just some sort of paraboloid here. The cutting place is some sort of paraboloid here. So this is the cutting place in plane of y equals to and plane of x equals 2. And then later the coordinate planes is saying that not really going all the way to that negative piece, is just really stopping the coordinate plane which is behind of this and the coordinate plane which is behind of this. So that's why it's stopping there in the coordinate plane. Make sense? Maxine? Does it make sense, Maxine? Okay. Any other question? So let's just take about, let's say 10 minutes break. Is that fine? 7 to 10 minutes break, okay? So we haven't stopped it for 1 hour. Let's have, 1 hour and 15 minutes. So let's just take a 10 minutes break, and then doesn't mean I go anywhere. So I'll stop just teaching, okay? But you can keep going and ask questions. So now it's 3:44. I will start at 3:54.
When we come back from the break, could you do another problem where we have to find the limits of integration and graph the function again?
So this is done. So let's just find before people come back. So let's find a good question, huh?
Thank you so much.
No worries. I think I lost your question. What was yours? Don't expect me, Darian, to answer the question right now, okay? This is just... What I know about the exam, the whole purpose is keep everyone to be exactly on the same schedule, and then we don't want to get behind for any of the schedules, because you have planned for your life, for your graduation, and then the finals are exactly in the same place, so no one can move the finals. We want to be ready for that time. So that's why we are making the classes exactly right in schedules, and then every single thing that we have planned to do is just going to be similar to what we have done before. Okay, so nothing will change except we don't see each other for a few weeks. Just the other question is why we have choose to be online classes when it's not really mandatory. That just they recommended strongly to make it online, and that's just really to test what we can do. And I think this fortunately this goes really nice, but I'm just still waiting for you guys to give me the feedback. As of now, for the morning, and this is the second one, and then I haven't had any experience of this type of online classes, but that's just really testing to say which way works better. But there was no really reason to just say. I think something we need to start to learn, which is just really online classes. I thought I can just start from today. But still, again, still is just really testing. Everything is testing. The good thing about our classes, guys, is because we are having really every single thing online. 80% of the entire class is doing online. So we have voice thread, which is online. The group work discussion is online. So homework is online. All of the homeworks are e-submission, or assignments are e-submission. So this is really great that we don't have any problem. We don't need to change that much, except it's just really face to face. We don't see each other, but it seems as long as you can get connected and you don't have any problem with the Wi-Fi, you can just be here at the same time, and we can just write down the same thing that I did on the board right here on the iPad or whatever screen you have. But still, if someone is not available for some reason, this is recorded, and then we can just watch it later. And the only reason that I like it, because this is interaction, right? So you need to ask the questions, I need to ask the questions. I don't know, probably the other people seeing the chat too. So sometimes I'm reading questions and I answer it. Sometimes I forgot to read it and then answer it. As long as you are available, I will be available to answer the questions at the same time. But YouTube videos are again recommended to watch, because that gives you more examples. But it seems as of now, what we are seeing, students are really getting the same thing that they are doing during the class time. I hope nothing happened in technical problems I can record it as long as I can record everything. And then right now, I don't know how many students I have right now. So let me check one more time. I think most of the students, even more than the one that was available in the class, are here. So this is just showing we have really good attendance right now. And if you can keep going exactly, yeah, everything is just depends on the professors. I'm recording too, Ben. I'm just having the, oops, where is this recording thing?
Disneyland just closed.
Really? Did you check it?
Yeah, both parks.
Yeah, sometimes people take the risk and say, okay, so there is no crowd, people are scaring, so let's go and make it. And still, that's dangerous. That's really dangerous. I mean, it's not that much bad in our area yet. I mean, that's just what the news says, right? We don't have that much. I mean, in our campus, even we haven't had any report. I think this is a good news.
Yeah, I'd have to agree with you on that.
I know. Yeah, but the thing is, it says we have only 2% rate of dying people in this one book says. But the thing is, if it's 2%, you don't know where is it, right? So the problem is, I just yeah, because the chance of getting is 100%. If you are in the place that is there, so the chance of getting that one is 100%. I don't want to say something, but it seems I can't record again. I don't see recording. Where should I find this one? Sorry guys, I will leave the meeting and then I'll come back in a second, okay? So we need to start again. And what I'm looking for right now, where do we, Diana. 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 Anyone hear me?
Yeah.
You know
Yeah,
that
we can hear you.
yeah, Diana, this is interesting. I can't record, and I see you are recording.